our fifth example here, we have negative 3. So that's our a. So a is equal to negative 3. H in this case is going to be equal to 1. And k is going to be equal to 2. So we have everything happening here on this one. So let's get a quick coordinate plane sketched in here. Okay, so if we are at 1 with our vertical asymptote, because h is equal to 1, so we shift it 1 to the right. And then our k is equal to 2, so this is about 2 here. 2. So this is like our new axis. So we have our vertical asymptote, or VA, is equal to x equaling 1. And our horizontal asymptote, right, that's where our y is, that's k, it's going to be 2, so y is equal to 2. Okay, so now I'll almost treat it just like this is the new axis. So if I come over 1 to the right of our new axis, right, that's going to put us at 2. Okay, that makes my output going to be, oh, be careful though, this is flipped. Right, so please do not forget flipped, like I almost did there. So this is flipped. So that means we're going to be in this quadrant and this quadrant. So if I come 1 to the right, right, that's going to put me at 2 here, and that's going to put me at negative. So I'm going to go down. So it's the same thing, right? So we ignore this, we kind of ignore this. So if we come 1 to the right, okay, that puts me at 3. So that's going to be at negative 3 over 3. So that puts me at negative 1. So right there, and there is our stretch, because we got to go 3 spaces. Right? So we went down 3 spaces. 2 from here, 1, 2, and then down 3. Okay, and now if we kind of move over here, so we were at 3, and let's say we go over, and just so we know, it's going to be like I'm picking multiples of 3 to make my life easy. So what if we go to 6, right? If we go to 6, that makes this 1/2. So we're at like 1.5. So 6 and 1.5 is out here. We just need a sketch. I don't need to be that precise on this, so we're just get a sketch in here. And there we go, boom, like that. And this is our 1 must point right there. All right. So now if I go 1 to the left, that puts me at 0, doesn't it? Oh, nope, sorry, it puts me at, yeah, it puts me at 0. So if I'm at 0, that's going to be 3. That I have to go up. So 1, 2, 3. So we're already at 2. We're going to go 3, 4, and 5. So that puts me up here at 5. Okay, and then the curve comes down here and we stretch it out. So we're just going to go ahead and throw a curve in there. You kind of demonstrate that you have an understanding of how the curves are. So we have our vertical asymptote, our horizontal asymptote, and then we can go our domain. So our domain, once again, it's all our real, so double bar R, except, right? So we're going to exclude an x value. That x value is going to be that shift to the right of 1. So x cannot equal 1. So it's all real, except for range. It's everything except y equaling 2. Y cannot equal 2. So that's our domain and our range. All right, so now we can look at intercepts at this point. We can look at our intercepts. All right, so if x is equal to 0, so imagine that x not being there. So if x is equal to 0, I end up with negative 3 plus 2. For my y-intercept, right? So that's going to be 3 plus 2, that's going to be 5 right there. So my y-intercept's at 0, comma 5. The y-intercepts are usually easy to find because you're just making x equal to 0. All right, let's take a look at the x-intercept. A little more work to do the x-intercept, right? Because this is the y-int. I meant to label that. Okay, so now our x-intercept, it's going to take some work because y is equal to 0. So we're going to have 0 equal to a negative 3, x minus 1 plus 2. So what I'm doing here is I'm just going to go ahead and solve for my x, which is down here. So the first thing I need to do is move the 2 over. This is always first. You're going to move that k to the other side. First thing you need to do. So that's going to be 2 is now equal to negative 3 x minus 1. Now we're going to take the whole parentheses. I'm going to throw the whole denominator. I'm throwing parentheses around it because we're going to move the whole parentheses over to the left. So we're multiplying both sides by the parentheses technically. That will cancel out here, and then on the left-hand side now we're going to have 2 times x minus 1, and that's going to be equal to negative 3. So once we have that, we can go ahead and solve this, right? All right. So I'm not going to you can distribute through. I'm not going to distribute through first. I'm just going to go ahead and divide by 2. I can save myself a little step in there. So if I divide by 2, now I have x minus 1 equal to negative 3 halves. And then I have to add 1 to both sides to make that 1 on the left-hand side go away. So we have x is equal to a negative 3 halves. And remember, since we're dealing with fractions, you need common denominators to add and subtract them. We're adding in this case. And that's going to be 2 over 2, which is just 1. It's just a different one. It's a fancy one. So if I add those together, I would have x equal to a negative 1/2. So that will be my x-intercept. So that's going to be at negative 1/2. Let's put it up here. So it's going to be at negative 1/2, comma 0. And that's my x-intercept. So I have my x, y-intercept. I have my domain, I have my range, and I have my vertical and horizontal asymptote with the graph. And if you talk about translations, we shifted 1 to the right, 2 up, and we stretched it by 3 and flipped it over the horizontal asymptote.